Hi Lakewood Math 1 students, this is Miss V with video 12, and in this video I'm going to show you how to work linear equation word problems when you're given 2 points. So we want to use this technique when we're given 2 sample points, and we're going to call that x1, y1, and x2, y2. So in this first problem, problem number 13, we've been given 2 points. It says to surf the internet for 25 minutes, at an internet cafe, it costs $7.25, and for 40 minutes it costs $9.80. So I'm going to write these as points. It's funny how these word problems become so dated so quickly. There was a time when you would go to someplace like Starbucks and you had to pay to get on their internet. So those are my 2 points. My x is going to be the number of minutes, and my y is going to be the cost, because how much it costs depends on how many minutes. And so to do this, I'm first going to have to find my slope using my slope formula. So I'm going to label my points, because if I don't, I get them mixed up. And we have y2 minus y1. Hopefully I've said that so many times it's like in your brain. I have y2 minus y1 is over x2 minus x1, and that is equal to my slope. So I'm going to use my calculator to make my calculations just a little faster, and I'm going to say $9.80 minus $7.25 is $2.55. And this looks like it's 15. So 255 divided by 15 is equal to 0.17. Looks like my slope is 0.17. So now that I've found that, I'm going to use my point slope form to find the equation, and I'm just going to need one of these points, and honestly it doesn't matter which one, we'll still get the same equation. So I'm going to say y minus y2, just for consistency's sake I'm going to choose y2, is equal to 0.17 times x minus x2, which is 40. So the first step is to distribute my slope of 0.17, so I get 0.17x minus, and then 0.17 times 40 is 6.8. So that's where we are in our equation so far. And now we need to add 980 to both sides. So we get y is equal to 0.17x, and we have negative 6.8, and we're adding plus 9.8, and it looks like we get 3. So it looks like our equation is 0.17x plus 3. So if we look at this, we can tell that the internet cafe charges $3 to hook up to their internet, and then we're paying 17 cents for every minute that we use the internet cafe services. And that's what this equation tells me. And then it says, well, how much is it going to cost if you spend an hour using their web service? So we're going to take 0.17 times 60 minutes and then add 3. And the answer is $13.20. So I just put 60 minutes right there to get $13.20. And that's how much an hour costs. So, well, what I'd like you to do is I would like you to pause the video. I would like you to try the next 2 on your own, 14 and 15. And I will put the answers to 14 and 15 up when you resume the video. And here are the answers to problem 14 and 15. It says water boils at 100 degrees Celsius or 212 degrees Fahrenheit, and water freezes at 0 or 32 degrees Fahrenheit. If the weather forecaster says it's going to be 25 degrees Celsius, write and solve a linear equation to find out what the Fahrenheit temperature is. So my 2 points are boiling, which is 100 degrees Celsius, 200 degrees Fahrenheit. So in this case, I'm using X as C, and my Y value is F. And then my other point is freezing. So 0 degrees Celsius is 32 degrees Fahrenheit. So I go through the same process. I use y2 minus y1 divided by x2 minus x1. And if I make this x2, y2, and this point x1, y1, I avoid my negatives. You can do it the other way around. You'll end up with the very same answer. So I end up getting 9/5 as my slope, and you should just leave that as a fraction. And then if I put that in point-slope form of my equation, I find that y minus 32 is equal to 9/5 times x minus 0. So I distribute 9/5, and I get 9/5 x, and I distribute 9/5 to 0, and of course get 0. So then I have just to add 32. So if I want to know what the Fahrenheit degrees are when it's 25 degrees Celsius, I can simply put in C for my X value, a C of 25. So I'm going to do 25 times 9 divided by 5. And then I'm going to add 32 to that, and that will give me 77 degrees. And that's exactly what we did on this side. In the next equation, or the next problem, we have 2 points that indicate our car value. So after 3 years, our car value is $1,500. That's one of my points. And after 2 more years, which would be a total of 5 years, my car has depreciated to $11,000. So I need to find my slope. And here I did y2 minus y1, which is 4,000, and x2 minus x1, which is negative 2. So I end up getting a slope of negative 2,000. That means every year I have this car, it decreases in value by $2,000. And now I use point-slope form of the equation. Y minus 15,000 is equal to negative 2,000 times x minus 3. So I use this for x1, y1 in my point-slope formula. And then when I go ahead and do the distribution and add 15,000 to both sides, this is the equation I get. So my car started out, it looks like my car when I bought it was worth $21,000. And then to find out what its value will be after 8 years, I would put in 8 for x and find that after I sort out this arithmetic that my car's value was $5,000. So that is how we do 2 points. I would again like you to pause the video, and when you do, I'm going to show you the answers to the next page. So here's the answer to 16. You can pause and check your work. I'm also going to show you the answers to 17, 18, 19, and 20. And again, you can pause the video and check your work. This is 17 and 18. It looks like in 18 we have 2 points, And we're going to use point slope form. It looks like in 17 we have been given two different quantities that are changing, so we're going to use standard form. In 19 and 20 we were given a point and a slope, so slope-intercept form is the greatest choice there. And here we were given slope and a point, so we'll use point slope form. So if you have questions about how to tell which equation is going to be most convenient, I'd like you to ask them in class tomorrow. That's all. Oh, I promised you some answers, didn't I? I think I promised you these answers to 11 and 12. So you can pause the video and check your work here. Thanks for letting me go over by a minute.